Willkommen zurück, meine Damen und Herren, liebe Teilnehmerinnen, liebe Teilnehmer zu den Irradiation Service Days, Tag 2, Strahlenvernetzung. Wir haben schon eine ganze Menge gehört heute und wir machen weiter zunächst einmal mit der Auflösung einer Slido-Frage, die wir Ihnen gestellt haben. Ist Strahlenvernetzung bei Ihnen schon ein Thema, schon im Einsatz? Und wir wollen ganz kurz uns die Ergebnisse einmal anschauen. Ja oder nein war einfach die Antwortmöglichkeit. Und wir schauen mal, was sich da tut. Nein, 60%, ja, 40%, vielleicht sogar eine überraschende Zahl, 40% schon mit Strahlenvernetzung unterwegs. Wertvolle Daten, natürlich für uns auch. And at that point I want to switch back to English with our topic, second source crosslinking of continuous products, qualification, quality assurance. This is our topic now. With two speeches. First off, we have Roger Bryant. He has a degree in electrical engineering from Southampton University and is a chartered engineer and member of the Institute of Engineering and Technology. And he started working with electron beams cross-linking of wire and cable with Pirelli as early as 1982, quite some experience, and he continued the electrobeam cross-linking sections of Tyco and then Huber&Suhner. Welcome. Also with a presentation from BGS, Claudia Huber. She studied technical business administration and has been working at quality assurance at BGS since 2015, and since 2022 she has been responsible for cross-site complaints management, and before joining BGS she worked in the chemical industry and studied to become a chemical laboratory technician and industrial forewoman for chemistry. So without further ado, Roger and Claudia, the floor is yours.
Thank you.
Thank you.
Okay, so as was said, we're going to talk about second source cross-linking and the things you have to think about when you wish to put this into practice. So I'm basing this on the fact you already have the products, you already cross-link them, and you're either looking for extra capacity because of growth or backup in case of machine breakdowns. I certainly won't be giving all the answers, but by the end I hope you'll actually know the questions to ask. So the very basic checks before you consider using a radiation service provider. First, have they got an accelerator capable of the voltage range for your products? Will your product actually fit their handling system? Will your reels actually fit the payoff and take-up at that facility? And can they offer the tension range for your product? For most wire products, not a problem, but for tubing, fiber optics, it can be difficult. You can have many facilities as in the pictures below, a large, maybe 3 or 4.5 million volt machine in a concrete cathedral, or a small 500 kilovolt self-shielded machine in steel. So a big range of machines to look for. If you then find the company you're looking at has machines that meet that, you then need to look at the more quality side of it. How do they actually control the process? Are there tolerances for the key parameters? High voltage scan, beam current, line speed, and more critically, how is the relationship between beam current and line speed controlled? Because this actually sets the dose the product receives. So it needs to have a definite system, definite control, and with limits on it. Then the next one is for your product. Is there a recipe system? How do they deal with the recipes for your product? How are they linked? Is there barcodes? Other forms of things, RFID. Is there a data logging system for the process? What is logged and how often? And does the Radiation Service Centre have a quality system? And if so, to which standards? Do you need a specific standard for railway products, automotive products, maybe aviation? There. And then how do they actually identify the products? You put a reel on a lorry, it arrives there, how do you know the correct identity remains with it, it goes to the correct recipe, and then also for them, how are uncross-linked and cross-linked products separated? For radiation service centres that deal with sterilisation, normally have a very efficient system for this. Others that just deal with cable products may not be so good, but it's a critical question to ask. And finally, what test facilities are available? Do you need the cross-linking supplier to carry out testing, or will you do goods receiving tests when you get the product back to you? So if we've managed to achieve all those, we can then think about some trials. So if you're making the product, you have some idea about how it should be cross-linked, what dose it needs, or the parameters you cross-link it at. So you need to start discussing with the service center how you can translate your experience to their machines to give you a start point for trials. The best option, if you have it, is a computer-based dose simulation program where you can actually set the geometry of the machine into the program and look at the dose distribution around the product. But then, unfortunately, not many people have this. It's quite a lot of effort to develop, and most people apparently don't have the resources so to do. And then for your trials, if you've got a target dose to start with, you need to find some optimum parameters and what steps either side of this to use. If you're fairly confident of your initial guess, plus minus 20% is a good guess. Yeah. If you are not so certain, maybe you want to do 5 trials or spread it to plus minus 50% to start with. And then you also need to decide what testing do you actually require for the first trials. Must you do a complete type test? Are just the basic mechanical tests, hot set, elongation at break, enough? Or do you have to do something special for your product, maybe media resistance, cold bend? So there's a bit of thinking there. And also, do you need to check the dose uniformity around your product? And if so, how do you do that? Because there's quite a number of different designs of underbeam handling systems, and different products will react differently to different systems. I wouldn't say there's a best or a worst of them, but they're most definitely different. And then when you're fairly happy with your first trials, how can you actually qualify the product for production? What needs to be done? Are, again, the basic mechanical checks enough? Do you have to do other tests, media resistance, cold bend? Must you do a complete type testing with an external proof house? And then again, what standards should the testing be carried out? You should know this if the product is already defined, but maybe you're moving to a different country and other standards will apply. I mean, Underwriters Laboratory, DIN, British standards are some fairly basic ones of it. Or maybe your internal quality system states the level of testing required and what they actually need to test. Just the smallest and largest of a product family, or must every individual product be qualified? So we've now got a stage beyond. Okay, we've now qualified. We have to actually start making product with the Radiation Service Centre. So you have to tell them what you're sending them and when, how are you actually identifying your products and drums. Say again, do you use just paper stuck on it? Barcodes, nowadays maybe RFID is possible. And then when it reaches the service center, how do they link that product to a recipe? Is it by hand? Is there a chance of paper getting crossed so it gets the wrong dose? A number of things to look at and understand for that one. And then when it's actually in production, if they start with your product, do they start with an empty facility with just a lead wire in it? So your product always runs to the correct parameters? Do they try and join products together to save time? If so, how do they set the recipes? Or do they always use a lead wire between products? And again, as I said before, with the data monitoring, how is the process monitored? What information do you actually get? Do you get a certification that says the dose was within this tolerance for the entire product? Do they just tell you if there was a problem and something, say, went wrong with it? And the same, what happens if the product breaks during cross-linking or it is damaged in some way? How is that dealt with? How is the product segregated? How is it sent back to you? What's the procedure for that? We all hope nothing's going to go wrong with it, but unfortunately it does. And yes, we have to deal with that. And then other parts for your side of the facility is, does your product have to go on a specific spool to fit a specific machine? Maybe in your factory, you can use 3 different spools for this product, but the service center can only use 1 spool, so you have to make production control for that. And also you need to have sufficient empty spools at the Radiation Service Center that they can deal with problems. If the product breaks, it must come back on 2 spools, they need an extra empty spool. So this has to be thought out at the beginning. And then what testing can be carried out at the cross-linking facility? If you require special tests, how can this be arranged? And this will be dealt with in the second half of the presentation by my colleague. And if the tests cannot be carried out at the Radiation Service Centre, you somehow need to arrange them as your goods receiving inspection. And then in your quality system, merge all the test results from the previous extrusion, from the external cross-linking, and from the goods receiving inspections into one coherent document. And again, with this, it follows how are the return products to be identified. If you have individually labelled spools, it will always come back on a different spool. If you have pieces of paper, you have to make sure the pieces of paper follow. So it needs a bit of thought again. Once the product leaves your facility, goes onto a truck, is taken somewhere else, unloaded, comes back, you need to be able to maintain the identification. And also you need to be able to re-enter this data into your production control system when you get the spool back. And finally, a few little thoughts, also quality related on logistics. You need to plan in your system the extended time it's going to take from cross-linking. Maybe your facility says we can arrange to cross-link the spool internally in 24 hours. If you're sending it away, I would say probably 3 weeks. A week for transport out, a week in the facility, a week back. So that's quite a big change in your production schedule. And again, storage needs to be arranged. Can the cross-linking provider store your product if need be, or does it have to be sent back relatively quickly? That's another point for discussion. And your product may also have storage limitations. So it may have a maximum storage temperature, or there may be it has to be cross-linked in a certain time, or it all just sticks together on the spool, or doesn't meet its requirements. Again, this has to be discussed with the supplier. If you've just shipped them a truckload of product and the machine breaks down, what do you do? How do you know when it's going to be running again? Do you have to have the product sent back and cross-link it yourself? And then the final one, which creates even more of the fun, if the facility and your facility are in different countries, and you have to deal with the customs requirements, that we send out 10 spools, and it comes back that the cable's broken, it comes back on 11 spools. How does that clear with the customs people? So lots to think about. And so thank you for listening to my short presentation, and then I'll pass over to Claudia for discussing testing.
Thank you, Roger. Yeah, thank you for explaining the topic from a client perspective. I will now talk about BGS perspective and the important topics in the quality assurance. Yes, after the processes and properties desired by the customer have been agreed, the next step is the realization and implementation of the customer's wishes in quality assurance. As the name suggests, the aim of quality assurance is to ensure the quality of the radiation service. This is done, among other things, via laboratory analysis, which BGS carries out in its own laboratories on all sites at the customer's request. The area of quality assurance includes laboratory analysis for product release, as well as other topics such as deviation processing, customer communication, plant inspections, audits, and a few more. In the case when a customer would like to irradiate a new product, we have to ask the following questions for a smooth implementation in the routine. The question number 1 is, which laboratory tests does the customer want for the order release? The second one is, can additional customer-specific laboratory tests be implemented? And the third one is, does the customer have any special concerns or requests in addition to our routine process? So let's start with question number 1. Which laboratory tests does the customer want for the order release? First of all, the customer must inform us which analysis he needs for the release. And if desired, a target value can also be specified for the respective analysis method. After irradiation, the irradiated product samples are collected by the quality assurance for the analysis. And as soon as the measuring is finished and within the specification, the customer receives the approval from BGS for delivery of the product. At the same time, the customer receives the irradiation certificate as proof of the correct irradiation. Laboratory analyses that are carried out for tube and cable products are, for example, the degree of crosslinking, the longitudinal shrinkage, and the measurement of thermal expansion under load. So let's go on with question number 2. Can additional customer-specific laboratory analysis be implemented? This question arose when Huber&Suhner were planning a product qualification with BGS. A previously unknown measurement method was to be implemented in our company. So this analysis is called the soldering iron test, and it is used as a surface test on the cable sheath. It consists of a soldering station and weights, which are positioned on the handpiece of the soldering iron for a defined load. The soldering iron is placed vertically, as you can see on the picture, on the test object for 3 seconds. And this whole thing is carried out 3 times offset by 120 degrees over the entire test piece circumference. Also, Huber&Suhner provided the work instruction for this test method. They also provided the equipment, and we, in our company at BGS, we were training and implementing this test method afterwards. The logistical issues have already been addressed by Roger. The clarification of the logistical process results in the handling of special concerns or requests for the routine process. For example, does the customer want to collect the goods before the laboratory results are available? If this is the case, a so-called pre-approval can be stored for this customer. This means that the customer can pick up the goods in advance after processing by quality assurance in the ERP system, before the laboratory analysis are completed. So the goods are then immediately available for sale or for use after receipt of the complete irradiation certification by BGS. A delay by the duration of the transport can so be avoided in this way. This was my part from BGS perspective to this topic. Now we can go on with the open questions.
Thank you so much. Yeah. And
You're welcome.
we have a couple of questions that came up, and I'd like to start with you, Roger. One question is regarding how long did it take Huber&Suhner to introduce this customized test method?
This test, I think, probably took about 2 months to bring into place once it had been discussed and organised. So we had to make sure we had the equipment available, and the documentation for the test was already available because we use it in-house. Mm-hmm. Then it had to go to BGS and the training carried out. So I think probably 2 months.
Yeah, I can say it from
Really
BGS
quickly.
perspective,
Yeah, sure.
maybe.
Yeah.
I would also say it depends on the test method, how long it took or how long it takes.
Yeah.
From this measure from Huber&Suhner, it takes several weeks.
Yeah.
Right.
Because we also have to clarify some points before implementation, such, for example, is it possible to map it in our ERP system, this new method, or is there also the necessary space or the personal, resource available?
To conduct a procedure like this for the manufacturer side, what amount of time does this entity need to calculate?
Well, the whole procedure for qualifying is a very open point. If it's a fairly simple product, we can probably qualify it for full production in 6 months. If it's a complicated product that requires verification testing by an external laboratory, then you're moving a year and beyond.
Yeah.
So it's very much on the product complications and certification. The internal fairly easy. External can become very long.
And then you hinted also, if it becomes international, multinational, then it's even getting more complicated with customs and everything, right?
Luckily now, more standards are becoming international. So if you can get the relevant approval, it covers most lands. But always, certain countries have their own test requirements, and will keep their test requirements.
Claudia, we have 3 sites of BGS, obviously, in Germany. Is there a quality assurance at all 3 BGS locations, and how do they work that together? I assume it's not done for every site individually, but somewhat collaboratively.
So yes, we have the quality assurance on all sites of BGS here in Germany. So they are linked really, really good to each other, so we can support from every site, and we also represent other QA employees from the other sites if necessary. It's a really good teamwork here.
So I guess Wiel is on a daily basis communicating with Bruchsal and so forth?
Yes, that's right.
Okay. One question that came up, especially for Roger, what is typical online cross-linking quality check in the production?
The actual online with cross-linking is not done, but at the end of a process, spools will typically be tested. Probably a hot set test, so hot elongation is a very good measure. Again, it's customer dependent. Interesting enough, one of the most common ones is stripping force for wire and cable, that the automotive industry is very interested in for all their automatic cut strip machines. This is one of their tests which doesn't really directly relate to the cross-linking process, but is quite a common one. Say the soldering iron test or something equivalent. There are many companies have different versions, all basically proving the product doesn't melt in some way or another. So those are typically carried out. Occasionally you'll carry out elongation to break and tensile strength. But generally that moves you away from what the machine operator will do and into what the quality lab will do. This always is a bit of a point. How much of the quality work can you or should you put on the machine operator, and how much should be separated from him?
Yeah. Going forward, what would you say, what are the goals or the perspectives for even more standardization of processes? Because it appears that it's still a very complex process and that you need to apply it very, very individually.
Yeah. I mean, the key to this is having an understandable process window for your product. So the basis of radiation cross-linking is, as you increase the dose, some properties get better, some get worse. So the bigger the window is where it is good, the easier it is to set parameters for the machine that say, if I control to this level, I know the product will pass, I don't need to test it. Right. However, with ever-tightening specifications, this window becomes smaller and smaller. So it comes to a point where you have to say, can I really guarantee this? Or should I do regular testing to confirm nothing has changed? I mean, ideal world, the calibration and maintenance of your facility means that everything is repeatable. Your compound source says that the extrusion and the plastics are repeatable, so we shouldn't have to do any testing at all. That's my ideal world. In reality, it's not a perfect world, so some measure of testing is required. The less that is, the less delay you have, and the less you pay for it. Without testing, the product is cheaper.
Obviously. Claudia, one more for you. Until when must the customer requirements regarding the desired laboratory analysis be communicated to BGS in order to have a smooth process?
So it should be definitely before the first irradiation order for routine receives at BGS, because you already heard which points we have to check before implementation of any testing method that is new. So it should be definitely before, and it's also important to talk about this topic already in the first meetings for the qualification of the product.
Roger, one word probably about, I get a new question here. During irradiation cables, are heating, ? If yes, what is your cooling process? Oh, that's a little off topic, but probably you can say something.
It does actually relate to this in a way that if, yes, as you irradiate the product, you're putting energy into the product so it's heated. Often for small products this doesn't matter. For large products it can be important. So if you in your own facility have a cooling system, you then have to make sure that the Radiation Service Centre can apply an equivalent cooling system, or you have to slow down the production, which is not what we want to do. So it's, in fact, another early check to make out that if you need cooling, you need to make sure that the Radiation Service Centre you're looking at can supply this. Because, yes, the product gets hot.
It does, yeah. I guess we'll leave it at that for now. Many thanks to Roger Bryant and Claudia Huber. Thank you for the presentation and the little Q&A round with the two of you. Thank you.
Thank you.